Let's solve some more MCQs from matrices. These are questions from previous papers. First question is, if matrix A is of order 3 by 2 and matrix B is of order 2 by 2, then the matrix AB is of order which are the following. Now this is talking about order of a matrix, and then AB is also multiplication of matrices. So let's have a quick recap. Order of a matrix will specify how many rows and columns the matrix have. So every matrix will have some number of rows and columns. So suppose here matrix A has order 3 by 2. That means it has 3 rows and 2 columns. So that's the order of a matrix. And matrix B is of the order 2 by 2. So it has 2 rows and 2 columns. Now, whenever we need to multiply matrices, which is A into B, when we are multiplying matrix A with matrix B, the compatibility for such a matrix is that the number of columns of the first matrix should be equal to the number of rows of the second matrix. And here it is true, the matrix A has 2 columns and matrix B has 2 rows. So yes, we can multiply the two matrices, A multiplied by B, and the result of this multiplication will give a matrix which has an order equal to the number of rows of the first matrix and the number of columns of the second matrix. So the result of this operation will be a matrix which has 3 rows and 2 columns. So option A is correct. Then moving ahead to the second question, again based on order of matrices, given there are these matrices, when we are multiplying, it results in another matrix. So the first matrix has these 4 elements, and we can identify that it has 2 rows and 2 columns. So the first matrix has an order of 2 by 2, and matrix X is some matrix we don't know, and they're asking what is the order of matrix X. So let's say that matrix X has order m by n, m rows and n columns, and the resulting matrix is a column matrix. There's a single column and there are 2 rows. So this matrix has a order 2 by 1. There are 2 rows and 1 single column. So now, because this multiplication is possible and we are getting a resulting matrix, that means that the number of columns for the first matrix is equal to the number of rows in the second matrix. So this m value has to be equal to 2. Only that is when this is possible. And the resulting matrix, if I see, has 1 column, and that is coming from the number of columns of the second matrix. So this has to be equal to 1. So the resulting matrix has 2 rows, that is coming from the first matrix, it has 2 rows, and the resulting matrix has 1 single column, and that is coming from the number of columns in the second matrix. So the matrix X has an order of 2 by 1. So option C is correct. Matrix X has order 2 by 1, 2 rows and 1 column. Then moving ahead, the next question, if these are matrices A and B, which of the following operation is possible? So we just discussed the compatibility of matrix multiplication. When is matrix multiplication possible and when it is not possible? But suppose for addition and subtraction, the compatibility rule is that we can add or subtract matrices only if both the matrices have the same exact order. Both the matrices must have the same number of rows and columns, otherwise addition and subtraction operations are not possible. Now if I see matrix A is a row matrix, it has only 1 row and 2 columns. So the order of matrix A is 1 by 2, 1 row and 2 columns, and matrix B is a square matrix of order 2 by 2, 2 rows and 2 columns. So obviously the orders are different, so automatically subtraction and addition operations are not possible. Multiplication may still be possible. So suppose if I am checking, can we do A multiplied by B? And since we have the number of columns of the first matrix equal to the number of rows of the second matrix, therefore AB operation is possible. But if I had checked for BA, matrix B has the order 2 by 2 and matrix A has the order 1 by 2. So number of columns of B is not equal to the number of rows of A. So BA is not possible. So only option C, the operation A multiplied by B, is possible.